Hey Algebra 1, Mr. Schachter back at you with an awesome, sweet video of Schachtering method number 2, the difference of two squares. Difference of two squares. This is the difference of squares. This is a nice method, and the reason is because to factor using this method, you actually just use a formula. I'm going to show the formula to you. It looks a little scary, but I promise you it's not that bad to use. Here's the formula. It says that a squared minus b squared is equal to parentheses a minus b, close parentheses, open parentheses, a plus b, close parentheses. So let's take a look at what this formula means. The left side of this formula right here, this is actually going to be the original problem. This is going to be what I actually give you to solve. So we're not actually going to be using that side of the formula. It's this side of the formula, the a minus b, a plus b, that your answer is going to be in basically in terms of this, okay? Now, it is notable to say that the order in which you have them listed doesn't matter. So you could do a plus b in front and a minus b in the back, and that would also be a correct solution in addition to this problem. So let's go ahead and see how this formula works by looking at an example. So the example is x squared minus 25. Step one of this is basically going to be to identify what a and b are in this problem, okay? So in order to figure that out, a is going to be what squared gives you x squared. Well, that's easy. That's x, right? X times x gives you x squared. And then the b value is what squared gives you 25. Well, that's just going to be 5. You guys agree 5 squared is 25, so that's going to make b equal to 5. Now, once you have a and b, all you have to do is apply the formula. Okay, so here's what the formula stated. So once we know our a is x and our b is 5, you just plug it in. So you plug them right in to the formula here. So you've got your x minus 5 and your x plus 5. So this right here is the only piece of the answer that you need. And this on the left was the original problem that you were asked to solve. So the answer to the question is x minus 5 times x plus 5, or x plus 5 times x minus 5 if you want to switch it around. Let's try another example. This example is x squared minus 36. So the first thing you have to do is ask yourself, what is a? Well, whatever a is, if you square it, you should get x squared. So therefore, a is x. And b, whatever b is, you should square it to get 36. So b is 6, because 6 times 6 is 36. All you have to do once you have the a and the b is use your formula. A minus b, a plus b. And this is the factored form. Now, if we take a moment and we actually use the distributive property on this, so we could distribute the x into these parentheses here. So this is going to be x squared plus 6x. And then we're going to use the negative 6 and distribute into these parentheses. So that is going to be negative 6x minus 36. And you're going to notice that the 6x and the minus 6x cancel, giving you x squared minus 36. So this factoring actually worked. We got the original problem. Let's try another example. This one is 81 minus 4a squared. So again, you have to identify what a and b are. So whatever a is, if you square it, you should get 81. So that's 9. And whatever b is, if you square b, you should get 4a to the second. Well, let's do this term by term. 2 squared gives us the 4, and then a squared gives us the a squared. So together, b would be 2a, because if I did 2a times 2a, I would get 4a squared. Then you use your formula. 9 or a minus b, or minus 2a, and then 9 plus 2a. Or vice versa, you could have the plus sign over here and the minus sign over here. It doesn't really matter. All right, so that is the difference of two squares. And the easiest way to identify that you need to use it is when the problem has exactly 1, 2 terms that are both perfect squares and a minus sign in the middle. All right?